Hello everyone. So in the last lecture, we defined vector and then we studied how to add two vectors, and also we saw that how we can resolve a vector into its components, and then we defined a unit vector. Then using unit vector, we also saw that how we can write a vector into its components form. Okay. Now today we are going to discuss further and we will understand that how we can multiply a vector by a scalar, that is a number, and how we can multiply a vector by a vector. Okay. So let us first multiply a vector by a scalar. Okay. So what does that mean? Multiply a vector by a scalar. Let us take a vector A, ax I cap plus ay j cap. Okay. So I will multiply now this vector by a scalar lambda. Then what is the meaning of this? This lambda is also a number. So it will get multiplied with ax and ay. Okay. So basically what I am doing is that when I will find the magnitude of this vector, this magnitude has become lambda times. This is the meaning of multiplying a vector by a scalar. So for example, if I take a vector to be 5i plus 2j, then multiplying this vector by 3 will give me 15i plus 6j. Okay. And when you find the magnitude of this vector, the magnitude will become 3 times. This is a meaning of multiplying a vector by a scalar. And at the end, we will get a vector again. Only its magnitude will become lambda times. I can also multiply this vector by 1 by lambda. So you can find the magnitude of this vector by 15 square plus 6 square under root. And when you find the magnitude of this vector, this will be 3 times of the vector A when you will find the magnitude of A by doing 5 square plus 2 square, the square root. Okay. So now I was saying that we can also multiply a vector by 1 by lambda. Okay, that is also the same meaning. So basically I am doing the magnitude 1 by lambda times. Okay. So this lambda can be 2, 3, any number, or it can also be 1 by 2, 1 by 3, anything. Only the magnitude will be changed. Now if I want to multiply a vector by a vector, okay, that has entirely a different meaning. And we will see that we can construct a scalar out of two vectors, and also we can construct a vector from two vectors. Okay. So let us look into that. So let us first construct a scalar out of two vectors. Okay. That is, multiply a vector by a vector. Okay. So now this multiplication is known as dot product of two vectors or scalar product of two vectors, and we write this as A dot B. Okay, this is called as dot, and this scalar product is defined as, I will take two vectors here, vector A, vector B, with angle theta between them. Okay. Now this scalar product A dot B is defined as the projection of vector A on vector B into the magnitude of B. Okay. So basically when I take the projection of vector A on B, it will be A cos theta, which we have already seen earlier when we resolve a vector along x-axis. Okay, taking this b as x-axis, I can resolve vector A along vector B. So this will be A cos theta, where A is the magnitude of vector A into magnitude of B. This is defined as dot product of A dot B. Okay, this is the definition. And we can check that if I do the other way around, if I take vector B dot A, dot product of vector B and A. So basically what I am doing, I am taking the component of vector B on A into magnitude of A. Then we will see that this also gives the same result, which shows that dot product is commutative. Okay, you will come across many different important quantities in physics. For example, work, which you all have already seen in grade 9th also and grade 11th also, that work is defined as the dot product of force and displacement, where yes. So if I take a component of B or projection of B on A, that will be B cos theta and into magnitude of A. So it will give you the same result. Okay. So now let us take two vectors. Vector A 2i plus 3j, vector B as 3i plus j. Okay, and let us find vector A dot B. Okay, this is our definition of dot product. Using this, we will see that what do we get here. 2i plus 3j dot 3i plus j. Okay, so here 2 into 3, 2 and 3 are numbers, so that will become 6. So basically what I am using, I am using a distributive law, which is a part of the definition of dot product. Okay, so 3 to 6 I hat dot I hat plus 2i dot j, 2 I hat dot j plus 3 j, 3 into 3 will be 9, j dot j plus 3 j into j dot j. Okay. Now we have already defined the last lecture that I yes, this is I. Yes. So we have already seen that what are ij, I hat, j hat. These are the unit vectors along x-axis and y-axis respectively. The magnitude of I hat and j hat is 1. Okay. And now we will use the definition of dot product. I hat dot I hat. How do we solve this? That by definition, A dot B is modulus of A into modulus of B and cosine of the angle between these two vectors. How do I find I hat dot I hat, magnitude of I, that will be 1, into magnitude of I again 1, and cosine of these two vectors, cosine of the angle between these two vectors, which is equal to 0. The angle is 0, cosine of 0 will be 1. So at the end I will get I dot I hat as 1. Okay. Similarly, I dot j, when I calculate using the definition of dot product, we will see that I and j are the unit vectors along x-axis and y-axis. The magnitudes are again 1 and the angle between these two vectors is 90 degree. Okay. So and we know that cosine of 90 degree is 0. So I dot j, this term will go off. Similarly, j dot I will also become equal to 0. We will be left only with two terms, 6 into I dot I will be 1, j dot j will again be 1. So 6 plus 9, that is equal to 6 plus 3 is equal to 9, okay, and that is a number. So this is how I can construct a scalar using two vectors, okay, and this is very useful thing. You will see that you will use again and again many quantities we need to construct in physics where those quantities are scalar and we will be constructing them using two vectors, and already I gave you an example of work done, which is a dot product of force and displacement, okay. Now one more thing we will learn about dot product, that by using the definition of dot product we can find the angle between these two vectors, okay. How do we do that? For example, if I have to find the angle between vector A and vector B, already we have calculated A dot B is equal to 9, and using this definition again I can find the cosine of the angle between A and B, okay. And how do I do that? From this definition I can write cosine of theta is equal to A dot B upon magnitude of A into magnitude of B. A dot B already we have calculated as 9. Magnitude of A will be 2 square plus 3 square, 9 plus 4, 13, square root of 13. And similarly we can also find the magnitude of B, that will be 9 plus 1, 10, square root of 10. From here you can easily calculate the angle between the two vectors, okay. So this was all about the dot product. We also call this as dot product as well as scalar product. Okay. Now we would like to construct a vector from two vectors, okay. For that we will define another term which is called as cross product, okay. Let us see how do we do that. Again I am multiplying a vector by a vector. But we will see that as a result of this multiplication we will get a vector. Multiplying a vector by a vector, this is called as cross product, okay. This is denoted by vector A cross B, okay, and this is equal to another vector C, and this vector we will see that the direction of this vector will be given by, so for example if I take A cross B, the direction of C will be perpendicular to A and perpendicular to B. So as I sweep my hand from A to B, the direction perpendicular to this board will give you the direction of vector C, okay. So but here what we have seen earlier in the in the case of dot product, that A dot B is equal to B dot A. The dot product of two vectors is commutative, whereas in cross product the cross product is not commutative. Why? Because when I sweep from A to B, my thumb points in the direction outwards, that is outside perpendicular to the board and outwards. But if I sweep from B to A, my thumb will point into the board. So the direction will be opposite and we will get an additional sign. That is why cross product is not commutative. If B cross A, that will be equal to minus C. Okay. Now let us take an example and try to calculate that what we will get. How do we calculate cross product? Let us take A is equal to 3i plus 2j, B is equal to 2i plus j. Okay, and if I calculate A cross B, 3i plus 2j cross 2i plus j. This is not a usual multiplication, okay? This is a cross of these two terms. Again, using the, by definition, cross product distributive, I can use that, okay? So when I do the cross product of this term with this term, 3 and 2 are numbers, it will give me 6 I cross I plus 3 I cross j plus 2 into 2 will be 4, j cross I plus 2 j cross j. Now here, yeah, if we have to find the magnitude of the vector C, the magnitude of vector C will be magnitude of vector A into magnitude of vector B into sine of theta, where theta is the angle between A and B. In the dot product, when I have done A dot B, vector A into vector B, we had cosine theta. There theta was the angle between vector A and B. Here again theta is the angle between A and B, but we have to take the smaller angle. In the dot product, we can take either angle, whether the smaller or big. It doesn't make any difference. Both will give you the positive quantity. But in case of sine, you cannot take the bigger angle because that will give you 360 minus theta, that will give you an additional minus sign. So you have to take the smaller angle between these two vectors. Okay? No. So here we have to add a direction eta hat, where eta hat gives you the direction of vector C and which is perpendicular to the plane of vector A and B. Okay. Now using this definition, we can find I cross I and I is a unit vector along x direction. Using the definition of cross product, this will give me sine of 0. Sine of 0 will be 0. So these two terms will cancel out, I cross I and j cross j. I cross j will give me, you can see that I, because the angle between these two vectors is 0. Both the unit vectors, they point out in x direction, and by definition of cross product, sine of 0 will be 0. Now here, in order to calculate I cross j, I vector is along x direction, x axis, and j vector is along y direction. When the magnitude is 1, but when I take the direction from I to j, I get a direction, the direction which my thumb points out, that is outward, and that points out in the direction of plus k cap. So I cross j will be equal to k cap. So I will get here 3 k cap, and j cross I will, if I sweep from j to I, my thumb points in the direction inside the board. So if the direction outside the board is positive k, inside the board will be minus k cap. So you will get from here minus 2 k cap, that will be equal to k cap. So when we have calculated the A cross B, okay, the magnitude, so this is, if this is equal to C, vector C, this is equal to another vector C whose magnitude is 1 and direction is given by k cap, k hat, okay, a unit vector pointing in the z direction which is perpendicular to both x and y. Okay. So this is how we can calculate the cross product of two vectors, and as a result we get another vector. In physics you will come across many quantities which are defined by using a cross product. For example, torque, you will study in rotational motion. torque is a cross product of two quantities, R position vector and force. Okay. Similarly, you will come across many other quantities which are defined using cross product, like angular momentum, torque. Okay. Now, using the cross product also you can find the angle between two vectors. How? As we have done earlier, we have calculated A cross B using K cap, using this definition, and then we can find the magnitude of A and B, and we can substitute in this definition and we can find the sine of the angle between A and B. Okay. We can see from the definition of dot product and cross product that the two vectors, if they are perpendicular to each other, their dot product is 0, and if the two vectors are parallel to each other, their cross product is 0. Okay. So, using all these definitions, we can define many quantities in physics.